introduction. So basically, ProxiFit is a proximity magnetic sensing system for weight exercise tracking. This work was possible thanks to great collaborators Nam, Jungeun, and advisors Professor Inseok Hwang and Young-Joo. So ProxiFit is a magnetic exercise tracking application that pervasively detects, classifies, and counts exercises on a commercial smartwatch or smartphone. Numerous sensing modalities have been adopted to track exercises. Then what is so special about magnetic sensing? If you consider practical constraints such as sensor availability on commercial off-the-shelf smartwatch and smartphones, and no instrumentation on equipment or gym site, and privacy concern at public gyms, basically magnetic and inertial measurement unit sensing are only the viable candidates. However, IMU actually has some serious blind spots. In fact, IMU can track exercises only if the device itself moves, hence the name inertial measurement unit. For example, shown butterfly can easily be tracked. However, there do exist exercises that leave the device stationary during exercise. Shown is a leg press where smartwatch stays still. Such exercises simply cannot be tracked with IMU due to the lack of motion. Surprisingly, our quick survey revealed about 30 to 50% of gym machines lack wrist motion, and thus they are unable to be tracked with conventional IMU-based method, which is rather substantial, in fact. So, okay, then, but how ProxiFit tracks exercises using magnetism? Most weight exercise equipment is made of ferrous metal or basically an iron. So ferrous metal has some faint natural self-magnetism which interrupts ambient magnetic field, and ProxiFit can detect such abnormalities using built-in magnetometers as shown in the post below the video to track exercises. With magnetic proximity sensing, we propose two modes of exercise tracking, namely wearable and signage mode for ProxiFit. Wearable mode extends coverage of smartwatch exercise tracking to lower body machine exercises and free weight exercises done on non-watch worn arm, so like the other side of the arm where you wears the watch. On the other hand, signage mode is a new off-body, off-equipment sensing mode where a user can mount smartphone to any location around equipment, basically, but we find it is better to preferably one with good screen visibility so that in signage mode, user can view contents such as exercise coaching video, for example, while exercise tracking is running in the background. Unfortunately, sensing magnetic field to track exercises is not as simple as replacing IMU with magnetometer in current systems. First, natural self-magnetism is not the same, even if they are of the same model from the same make. This means each instance of equipment should be trained with its own dataset, increasing training dataset requirement. However, this should be kept down with easily generalizable classifier, since we can only collect so much exercise data. I mean, after all, it is literally called a workout, so you cannot do an infinite amount of it. Second, magnetometer is noisy with drift. So figure shows magnetic trace during 5 continuous repetitions of hip abduction. Observe there still exists noticeable noise and drift even after frequency filter. Third problem is varying device orientations depending on how a user wears smartwatches and how they hold the handles of the exercise equipment. This results rotated magnetometer readings even if the equipment is identical. So let's see how ProxiFit pipeline detects, classifier, and count exercises under such challenges. First, workout detector detects workout segment with acceleration thresholding or autocorrelation depending on the mode. Then frame normalizer cancels out orientational variations by using gravity as a frame of reference and aligning magnetic data to it. classifier is designed to use principal component factor of magnetic trace as a feature. So this is because rather simple yet repetitive trajectories of exercise equipment ensured consistent principal component vector axis despite magnetometer noise. Notice principal component vectors, shown as arrows, are consistent despite noisy signal. Given consistent features, classifier can train generalized model for public only for, excuse me. So generalized model for public only from 10 repetition sets, or approximately 100 repetitions of training data from single person per each equipment. Repetition counter also overcomes noise by applying continuous wavelet transform, extracting periodic signals from noisy data. So we tested both wearable and science mode on 14 and 12 exercise each. And wearable mode showed 93.1% classification accuracy and 0.77 repetition error per 10 repetitions when it comes to the counting. And science mode kind of struggled to distinguish which arm, so left arm or right arm exercise, the dumbbell exercise is done with. But however, it achieved approximately like 100% accuracy if we ignore arm-sidedness. And counting error was 0.69 per 10 repetitions. ProxiFit was robust against many factors such as longitudinal aging, interference of nearby machines as close as 43 centimeters, and position and rotation variations of the device, and weather and user variables. Please refer to the paper for further details and numbers. So to sum up, ProxiFit utilizes magnetometer to extend coverage of exercise tracking and support exercise tracking on off-body and off-equipment stationary device. Thank you for listening, and you can scan those QR codes if you need information.
So thank you so much. Question?
I'm faster. So thank you for the work. And I have a question that I saw this drift. So I wonder, is this from a continuous set? And is that you observe their motion pattern? Is that also convoluted with their fatigueness one set weight, or is it really from the magnetic drifting?
So it is basically a drift of a magnetometer, and it is not a result of fatigue because it was a machine exercise. So fatigue would not affect a trajectory of the equipment because like it is a machine and it just moves along the rails.
Sorry, great presentation. I actually have another question. So regarding you say that there is a drifting as well as the hand position could change on the watch, does that mean during an exercise, our hand doesn't necessarily, it's stationary, always holding, you know, the handle or something? Like for example, I could do my 5th set and holding on my leg and while I'm doing leg press. Does that change the result, how the magnetometer changes, or would it still works?
You mean like you're like holding your leg during leg press?
Or like, because like our hand doesn't always stationary, right? Like, is this your assumption that it's always stationary, your hand is not moving, and or can we move our hand while we're doing this?
So what we thought is that like according to the manuals of exercise equipment manufacturers, they actually recommend you to hold the grip of the exercise equipment during exercise.
Quality of exercise.
Yes. Well, it's just for overloading, exercise overloading. It's possible that we're doing something not just holding the grip. We can like use hand to press the leg so that we can use as an assistant. So like this thing could happen for people who are very into weightlifting. And like if you move that, does that mean your whole system not gonna work because that it's based on magnetometer, right? So
All right. Thank you so much. Okay, so we're running out of time. All right, so thank you so much. Let's thank all the speakers one more time. Right. So at this time, I'd like to invite all the authors, presenters here, sitting here. Right. While we're preparing for the panel discussion, I'd like to understand whether the poster presenters are here. Poster presenter, can you raise your hand? Only one? Right. Poster presenters?